Hi everybody, welcome to day 2, 3.2 polynomial functions of higher degree. So we're going to look at end behavior and then we'll start talking about zeros of functions. So first, remind yourselves about end behavior. We're just going to use a little different terminology than last year. We're going to talk about far left and far right behavior of a polynomial function. And we break it up into two categories, even degree versus odd degree. So when we're thinking of an even degree function, picture a quadratic. We're most familiar with that. So when a quadratic has a positive leading coefficient, which way does it open? So you should be able to picture something like this. It doesn't matter what's happening on the inside in the middle. All we care about is the end behavior. So we would say as x is getting smaller, 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 so going to the far left, what's y doing? Well, y is going up, 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 up. So we would say far left and up, and then as x is getting bigger, y is also getting bigger. So we would say far right and up. Now, if it's an even degree polynomial but a negative leading coefficient, again, picture a quadratic with a negative leading coefficient, you should know that it opens down. Again, I don't care what happens in the middle, okay? So as x is getting small, 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 y is also going small, small, small. So we would say far left and down, and then what's happening as we go farther to the right, we're also going down. So far right and down. So even degree, the end behavior is even with one another, okay? Far left and up, far right and up, or far left and down, far right and down. Now if we look at odd degree polynomials with a positive leading coefficient, we could think of a line with a positive slope. Again, I don't care what's happening in the middle, but picture a line with a positive slope. What's it doing in the end? Well, as we're going far left, y is going down. As we're going far right, y is going up. So we have far left and down, far right and up. Now, what if it's a negative leading coefficient? So again, picture a line with a negative slope. What's it going to look like? Don't worry about the middle. I care about the end. So we're going to be far left and up, and we're going to be far right and down. So let's take a look at these next examples, and I want you to determine the far left and far right behavior of each function. Give it a try, come back and check answers. Okay, hopefully you got what I did. I recognize that this is an even degree polynomial. It's a degree 4. Our leading coefficient is negative. So an even degree polynomial with a negative leading coefficient, we're going to be far left and down and far right and down. In example B, the highest degree polynomial, I look at my highest degree term, so it's a degree 5, which is odd. My leading coefficient is 1, which is positive. So I have an odd degree with a positive leading coefficient, so I'm going to be far left and down, far right and up. Now we need to get into zeros of a polynomial function, and we're just going to look at the real zeros, okay, of a polynomial function. So we can find these by factoring, okay? They occur where the graph crosses the x-axis. So you hear me say x-intercepts or when y equals 0. So one thing to remind yourself of, the total number of zeros needs to match the overall degree of the polynomial. So if I have a degree 4 polynomial, I should have 4 zeros, okay? So let's look at this first example here. Find just the real zeros of each polynomial function. So the first thing I do, looking here, is I kind of make a note. Well, this is a degree 5, so I should have 5 zeros in the end. Step 1, we want it to be y equals 0. I want to solve for x. So I'm going to set the equation equal to 0. I'm going to go through and see if I can factor. I can factor out an x, and now I can treat this quartic like a quadratic, two numbers whose product is 9 but adds to negative 10, and the only difference is my factors are going to be an x squared and an x squared. So my two numbers are negative 9 and negative 1. So x squared minus 9, x squared minus 1. Both of these are a difference of two squares, so fully factored we have x, x plus 3, x minus 3, x plus 1, x minus 1. Setting each of those factors equal to 0, you can see I have 0 plus or minus 3 plus or minus 1. So let's count. Do we have 5 zeros? Well, there's 1. This plus or minus tells us we have 2. Plus or minus again, 2 more. So yes, we do have 5. I want you to go ahead and try B on your own. Pause the video and then check back to see how you did. Okay, how'd you do? So one thing to note, again, your degree is 3, so you should have 3 zeros in the end. I factored by grouping. I set it equal to 0, taking out the GCF of my first group, GCF of my second group, so fully factored, not quite fully factored, but next step of being factored. And now x squared minus 4 factors further, and setting each of those factors equal to 0 allows me to get 3 zeros of -4, +2, and -2. You'll need your calculator for this last example. So we're going to talk about turning points. I want you to use your graphing calculator to find the coordinates of the relative maximum or relative minimum for each function. Round values to the nearest tenth. So one thing that you should note is that a polynomial function of degree n has at most n minus 1 turning points. So for instance, if I have a quadratic, which is a degree 2, I have at most 2 minus 1, or 1 turning point, which makes sense because it's a parabola. Okay, so this is kind of a review for you with your calculator. I want you to plug this into y1, and you should get a graph that looks like what I've got here. You're going to want to use your calculate minimum feature on your calculator to calculate this minimum, and the calculate maximum feature to calculate that point. All right, and make sure or double check that you get the same values that I do. Same thing for part B. I want you to try this on your calculator and verify that you get a minimum, a maximum, and a minimum here. We'll go over the calculator portion in class next time we see each other, but give it a try on your own first. Have a great day.